So for example, number 1, we have the limit of the quantity 1 plus 3 multiplied by the square root of x times the quantity of 2 minus x squared plus 3x raised to the power of 3. So as we all know, the limit of a constant is the constant itself plus 3 multiplied by the square root of 1, which is equivalent to 3. And here for the limit of 2, we have 2 minus the limit of x squared, which is 1, because as 1 raised to 2 it is equal to 1, plus the 3, the limit of 3 multiplied by x cubed is equal to 3. So for example number 2, we have the limit of x squared minus 1 all over x squared plus 3x minus 1, which is the limit approaches to negative 2. Then we are going to substitute the value of x, which is negative 2, in the given functions. So our limit for number 2 is equal to negative 1. So for number 3, as you can see here in the example, we can actually directly substitute the value of z here in the given equation. So and then we are going to substitute here the value of z. So for the limit of number 3, we have the answer, which is 1. So actually in dealing with limits, you can actually substitute directly the value of z if it's dealing with a function, or like this example. However, in dealing with other limits, you cannot directly substitute the value of 2, wherein you can also manipulate the given function and then do the limit. So for our fifth example, we still have function which we're going to get a limit of 4 minus 3x squared minus x cubed all over x minus x squared, in which our limit approaches to negative 2. So here's our solution. 4 minus 3x squared minus x cubed, and then for the denominator. And then we're going to substitute the value of negative 2 to the x's. Minus 12 we have plus 8, as the answer of negative 2 raised to the cube is negative 8, then we have it negative, then it becomes positive. And then here for our denominator we have 6 minus 2, this will become 6 plus 2, and minus 4, which is equal to, we have here 4 minus 12 is equal to negative 8, and negative plus 8 is equal to 0. Then and our final answer is 0. So for the fifth function, we have the limit of 0. So our sixth example, we have here the limit of x cubed minus 7x squared plus 14x minus 8 all over 2x squared minus 3x minus 4, which our limit approaches to negative 1. So here's our solution. And then we are going to substitute the value of the limit of x as x approaches to negative 1 to the function. So we have here negative 1 raised to cube is equal to negative 1 minus negative 1 raised to 2 is 1 times 7 is equal to 7 plus negative 14 from negative 1 times 14. Then we have here minus 8 all over, we have 2 here, as negative 1 raised to 2 is equal to 1 minus negative 3 minus 4. And for our final answer, so here we have negative 22 and then negative 8, so this will become negative 30, and all over we have here 5 minus 4 is equal to 1. So our final answer is we have negative 30. So our limit for the function given function in 6 is equal to negative 30. So for our seventh example, we have here the limit of the square root of x squared plus 3 minus 2 over x squared plus 1, which our limit approaches to 1. So as you can see here, we are dealing now with radicand, but if we are going to substitute the negative d1 here, as we can see, this is negative 1. If this will be substituted to the denominator, this will result to 2, so it is safe as long as our denominator here is not equal to 0. So we are going to specify the limit between the numerator and denominator, but actually you can directly substitute it, but your teacher will actually find for a complete solution, then this will be the method. But for an easier way, you can directly substitute it. And for our second step, we can substitute the value of the negative 1 to the axis of the functions. Then we have here negative 1 squared is equal to 1 plus 3 is equal to 4, and then the square root of 4 is equal to 2 minus 2 all over negative 1 raised to 2 is equal to 1 plus 1, which is equal to 0 over 2. And for our final answer, we have 0 here as our limit. So our limit for the 7th example is equal to 0. It is safe that numerator will going to arrive at 0 in the numerator. However, if we are going to deal with a constant over a 0 here as our answer, it will going to be undefined and the limit does not exist. So if the numerator is only at 0, then we can conclude our limit is equal to 0. So for our last example for the limit of theorem, for the basic theorems, limits, we have here the limit of the square root of 2x minus the square root of 6 minus x all over 4 plus x squared. So if you're going to substitute the value of x here in the denominator, we will arrive with a constant which is equal to 16. So it is safe that we are going to use the substitution method in this function as long as the denominator itself will not be equal to 0. All over 4 plus x squared, and then we can substitute the value of 2 to the x's. So we have here multiplied by 2. So the dot here implies multiplication, or you can also write an asterisk. And then actually in writing a solution, it is important that our line here for division will be at the center of the equal sign here, because other teachers are actually strict in dealing with our solutions. So 4 plus 2 squared, and then we have the 2 times 2 is equal to 4, and then the square root of 4 is obviously 2. And then here also we have 6 minus 2 is equal to 4, and the square root of 4 is equal to 2. And then for our denominator, we have 2 squared is equal to 4, and plus 4 is equal to 8. And it will become 0 over 8 is equal to 0. So as long as our denominator will not be equal to 0, then we have our limit, which is 0. So thank you for listening. Hope you understand my examples. You can comment down below if you have any questions regarding my examples. Thank you for watching.